Namaste. This is Aprameya here, working as a lecturer in the Department of Mechanical Engineering at Sri Jayachamarajendra's Government Polytechnic, Bangalore. Today, I am welcoming you all for this session on Unit 2 of the course Computer Aided Engineering Drawing with a course code 20ME12P. So this is Unit 2, that is Introduction to Projection. And in Unit 1, we learnt so many things which is very basics for the engineering drawing. Like what are all the different instruments we have, as well as we understood what is the use of thin lines, different thick lines, hidden lines, and then we learnt what is scaling, then we learnt what is the different types of dimensioning, what are the different types of dimension systems like aligned dimension systems, unilateral dimensioning system, as well as we discussed chain dimensioning as well as parallel dimensioning, and at the end we learned how to draw the polygon. So this unit 2 where we are going to discuss about the projections, and this session 1 we cover the topics like introduction to projections, principal planes of projection and principal views. The course outcomes: at the end of this session, students are expected to learn about reference planes and they should get very good understanding about orthographic projections. So let us move ahead with the introduction. This is a snapshot of Unit 2 and the topic, that is 2.1, Introduction to Projections, Principal Planes of Projection and Principal Views. The contents of today's session 1 includes Introduction to Projections, Theory of Projections and types of projections we have, and what is meant by orthographic projections, and what is meant by reference planes, principal planes of projection, principal views, drawing orthographic views. And I am again repeating this line: in order to produce the quality engineering drawing, a student or an engineer who is a draftsman should know very basics about projections. Then only the engineering drawing what we are going to draw will have high quality. First we will discuss introduction to projections. Yes, the word projection, this is a new word. It is not a new word. I think you have heard this word projection, and in Latin language the word projection means to throw forward. In order to understand this word projection, I just want to give you a small example of a theater, cinema theater. And we had been to cinema theater and we have observed that from the behind of our seat, there is one projector which is projecting the reel of the cinema, and it is being displayed on the cinema theater with a rays of light. Yes, more or less the same concept is used in projection also. You can see in this figure, we can see a object is in between the observer as well as plane of projection, and a parallel visual light rays which is passing through the object is made to fall on the plane of the projection, and the projection is same size of the object. So this is the basic technique in projection, and projection help us to capture the size, shape of the object which is there in between the observer as well as the screen. And we know that engineering drawing is the graphical language used in the industry to record the ideas and information necessary in the form of blueprints to make machines, buildings, structures, etc. by engineers and technicians who design, develop and manufacture and market the product. Engineering drawing is a basic universal language. And these projections going to play a vital role in engineering drawing. Then what is meant by projection plane? We can define like this. A projection plane or plane of projection is a type of view in which graphical projection from an object will intersect. Okay, the projection planes are used often in descriptive geometry and graphical representation, and we know engineering drawing is a universal graphical language to communicate ideas, and this projections plays very important role in the quality of engineering drawing, and I can say the projections are the fundamental basics of engineering drawing. In this picture, you can observe again an object is placed between the observer and plane of projection. The lines of sight, or we can say the projectors, or we can say the rays of light will be made to fall on the object, and the projection from the object is made to be captured on the plane of the projection, and we can see the same view of the object on the plane of projection, which will give us more understanding about the size and shape of the object. I am going for theories of projection. Okay. In this picture, we have three figures. The figure 1, the display of the film. As I already explained, I already give the example of cinema theater where a photo film is projected by the projector onto the cinema theater screen. Because of the light rays which will pass through the photo film, or we can say the cinema film will be projected on the cinema screen, or we can say the white screen. Okay, that is the display of the film, and we can understand with the same example the figure 2, that is picture plane. Here a source of light will be placed behind the object, or we can say object is placed in between the source of light and picture plane. When the light rays passes through the object or passes on the sides or edges of the object, the same object is captured on the picture plane. Okay, and in figure 3 we can see that is what front view. Yes, it's a totally a new word or a new term. I can say the front view. The same techniques is used to capture the front view of an object. Again, why we need to capture this projection? I already told, in order to capture the size and shape of the object in a better way, we have to capture the projection of the object. You can see in the figure 3, the source of light passing on the edges of the object is made to fall on the picture plane of projection, and we can call it as front view. So slightly we are moving you to the concept called orthographic projections. Now before discussing about the orthographic projection, we'll understand what are all the different types of projections we have. So generally the projections are classified or divided into two important subcategories. That is, first one is pictorial projections, and which is again divided into perspective projection, isometric projection and oblique projection. And another main category of projection is divided as orthographic projection. For the engineering drawing, orthographic projections plays very vital role. And again, orthographic projections are subdivided into pictorial projection and orthographic projections. So let us understand what is meant by pictorial projections. Okay, the projection in which the description of the object is completely understood in one view is known as a pictorial projection. In pictorial projections, we have only one view. So like how we are going to capture our images with the digital camera. So generally we'll take one wave and that wave will give the clear picture. That single wave will give clear picture about the object. They have the advantages of conveying an immediate impression of the general shape and details of the object, but not its true dimension or sizes. But in case of orthographic projections, ortho, O-R-T-H-O, ortho means right angles. Right angles andre 90 degrees. So ortho means right angle and orthographic means right angled drawing. So ortho indicates right angle and orthographic means right angled drawing. It is a form of parallel projection in which all the projection lines are orthogonal to the projection plane, resulting in every plane of the scene appearing in geometric transformation on the viewing surface. So, in order to understand very simple manner, ತುಂಬ ಈಸಿಯಾಗಿ ಆರ್ಥೋಗ್ರಾಫಿಕ್ ಪ್ರೊಜೆಕ್ಷನ್ಸ್ ನ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದಾದ್ರೆ, the ortho means right angles. So here orthographic projection, which generally means right angle drawing, means we are taking what is the views we are observing, what is the size and shape of the object we are observing at right angles to the viewing plane, and that will be projected on the projection plane. So the orthographic projections means right angled drawing. I am repeating it. Orthographic projection is very important for the engineering drawing. We can say it is the basic fundamental basic of engineering drawing. Next, I just want to explain what is orthographic projection. Orthographic projection can be defined as is a parallel projection technique. It is a parallel projection technique in which parallel lines of sight are perpendicular to the projection plane. So there will be an object, there will be an observer, and the object is placed in between the observer as well as the projection plane. Orthographic projection is a parallel projection technique in which parallel lines of sight are perpendicular to the projection plane. For projection plane, the lines of projection technique will be parallel, or you can say it is perpendicular to the projection plane. So you can easily understand what do you mean by orthographic projection by this image. You can see the 1, 2, 3, 4, 5 lines which are parallel lines of sight which are projected perpendicular. These lines 1, 2, 3, 4 lines which is coming from an object. These lines are parallel lines of sight which are perpendicular to the projection plane. The projection plane is in some dim in color that you can observe. The 1, 2, 3, 4, 5 lines which are parallel to the object is falling perpendicular to the projection plane. So this is what orthographic projection. Now we'll understand principal planes of projection. So then what do you mean by principal plane? A plane is an imaginary and invisible clear surface. So every plane what we are talking is an imaginary plane. It's an invisible clear surface. Okay, the drawing constructed on this imaginary curtain is transferred on the drawing sheet. Now we are assuming a imaginary invisible clear surface as a projection plane, and we are transforming the image what it is formed, or the image which is captured on that projection plane. That image is being transferred to our drawing sheets. So this plane can be put in different positions. So generally the first plane we can call as frontal plane or vertical plane. Such a plane which is placed in front of an object while projections are drawn is called frontal plane. Likewise, we have horizontal plane. This is a plane which is placed upward or downward in the horizontal position of an object. The top view of the object is constructed on this plane. So I am repeating this word. In the principal plane we have frontal plane, or we can call it as vertical plane. So such a plane which is placed in front of an object while projections are drawn is called frontal plane, and another important plane we call it as horizontal plane. This plane which is placed upward or downward in the horizontal position. Horizontal means on the x axis of an object. Top view of the object is constructed on this horizontal plane. And another plane we have profile plane, such a plane which is placed to the right or left of the object. Side view of the object is drawn on this plane. So we have principal plane means we can imagine three planes. That is one vertical plane, we call it as front plane also, because we are going to capture the front view of an object in the frontal plane. And we have horizontal plane, so which will be parallel or placed upward or downward to the horizontal position, and we are going to capture the top view of an object. Likewise, we have profile plane, such a plane which is placed to the right or left of the object. Side view of the object is drawn on this plane. So in order to have better understanding, I am giving this example. You can see an object is there and we are viewing from the right side, bottom side, front side, left side, top side and rear side. So we have almost 6 different observing positions. Here the front view of that object is prepared by placing the object in front. The length and height of the object are shown in this view. So generally we are going to capture the length and height of the object in the front view. In the top view, this view is prepared by looking to the object from the upper side. So here we have object and we are looking from the upper side, or else you can imagine you place some object here and you put a torch on it. You just put a torch from the top side of the object, then you are going to get what is there in the top side will be projected on the horizontal plane or top view. So we can say the length and breadth of the object can be shown in top view. And the third important view is side view. In this view is prepared by looking to the object from the right side or left side. If there is an object, you can prepare a side view by looking the object at the right side or the left side. The breadth and height of the object can be captured using the side view. In order to have a totally clear understanding of this front view, top view and right side view, I just want to explain this image. You can see we have a object at the center and this object is in between the projection plane and the observer. And these arrows which are in the red color indicates how we are looking at the object in order to get our corresponding projection on the projection plane. Now we'll understand what you mean by front view. Yes, so here we have front view and you can see an observer is standing on the left side and is observing the left side of my slide, okay, left side of this image, and observing this object as a front view, and the same projections are captured on the projection plane. I am already explained you the projection planes are imaginary planes, but what we are going to do is we are captured projections are transformed onto the drawing sheet. Here in this view we can see this object like what we got the projection in the projection plane. You can see this front rectangle projection is a rectangle. Here we have a chamfer. This total length we can observe in the projection plane, and the most of the information like width, length, thickness can be identified using the front view. And we can see, as we already discussed, another important view is top view. That is, I gave an example. Hold a object and put the torch from the top side. Okay, likewise you can see this arrow which is pointed from the top, and by the top side we can see L type of section and that is projected on the bottom plane, or we can call it as horizontal plane. Okay, so we are capturing the top view from the horizontal plane. Likewise, as we discussed, side view. Side view may be the right side view or it may be the left side view. In this example, we are capturing the right side. Right side view means the observer is looking the object from the right side, and this, what is he is going to look, what is the things he is going to identify in the right side, that will be projected on the right side view. And again, that is an imaginary projection plane, and we are converting or we are transforming that particular projection on the drawing sheet. And again, I am giving you very important information. This front view, top view and side view is used to completely understand the size, the shape and the features of the object of which we are creating the engineering drawing. And I am telling, this is the first step. We can call it as a fundamental step, very important step of an engineering drawing, where drawing the orthogonal views and identifying the different views in order to capture the maximum information of a object in terms of size, in terms of shape and in terms of special features is the first key of success for the quality engineering drawing. I hope you understood the concept of front view, top view and side view. So in order to have better understanding, I am again giving some more example how we can draw the front view and how we can draw the top view. In the left side image, you can see the object parallel lines, the lines from the object which are parallel to the edges of the object is captured or is captured on the vertical plane, and we call it as frontal view, or it is nothing but front view. The vertical plane and horizontal planes are as principal planes of the projection, or we can call it as reference planes. They are always transparent and at right angles to each other. The vertical plane and horizontal plane is always vertical. We can say right angles. They will be right angles to each other. The projection of vertical plane is designated as front view, and the projection on the horizontal plane we call it as top view. So in this example, you can see this is the front view which is projected on the vertical plane, and this is the top view. It is a square and it is being projected on the horizontal plane. And you can see the vertical plane and horizontal plane are at right angles to each other. And in order to draw it on the drawing sheet, we are moving that horizontal plane, and we can see at the end we have front view and top view with the XY reference line. So this is the way how we are going to draw the front view and top view. So this is the final slide and this is the last example. And here you just give your concentration to understand the different views, or we can call the orthographic views of an object. In the left side, you can observe a object is placed in between the observer and the vertical plane. Okay, so the word front is there, that is the direction of view. The observer is looking at that direction, and you can easily say the front direction. We can see a rectangle. That rectangle is projected on the vertical planes, and that is called front view. And as I already told, in order to capture the top view, you have to see the object from the top end and you have to give that projection on the horizontal plane. And in this picture or example, you can observe the word TOP, top, and if you view from that angle, you can see a rectangle which is projected as a B in the horizontal plane. And again, we have two side views, that is right side view or left side view. Here, with respect to the observer, we are watching the left side view which is projected on the right side vertical plane. Okay, so right side plane, and we can see the rectangle which is marked as the C will give us the left side view. So when we open these planes and place it over on the drawing sheet, it will look like this. Always vertical plane will be on the top of the top view, and A is the front view, and B is the top view, and C is the left side view of the object, and all together three views we call it as orthographic views. Yes, you learned in today's class what is the basics of orthographic views, what are the different kinds of view we have, and how to draw, understand the front view, the top view, and left or right side view of an object. And thank you for watching.